Thanks again, everyone, for joining us here today for our webinar on serverless workflows. My name is Chris Munns. I am a principal developer advocate for serverless here at AWS. I'm joined here by Forrest Brazeal from Trek 10, who is going to be leading this webinar for us. And the purpose of today's webinar is to cover kind of a big picture, quick run through of what it looks like to build and deploy a serverless application using various different tools and services here at AWS. First, I'll hand it over to you for a little bit more about yourself and to kick us off today.
Perfect. Thanks so much, Chris. As Chris mentioned, I work for a company called Trek 10. We're kind of leading experts in the serverless space. And I'm also what's called an AWS serverless hero. And that just means I spend a lot of time working in the serverless community, helping to educate and advocate for these technologies. You may know me from A Cloud Guru. If you've done cloud training through them, I write for their community publication and also draw cloud cartoons that you may have seen floating around on social media. So due to the nature of my work, I spend a lot of time going around the U.S. and beyond talking to companies, large enterprises, small companies that are just dipping their toes into the serverless space. They're looking at migrations. They're looking at potentially getting their first greenfield apps up and running. And they often wind up with a lot of the same type of pain points. I've got a few of those summarized here. We'll have people try to figure out how to get multiple developers or even multiple development teams collaborating in the cloud. You don't necessarily have those local development workflows that you're used to. Everything's very different. People looking at how to enforce safety, security, auditability, all those ITIL type governance things they need for change management. What does that look like with serverless? How should I logically manage the resources that make up my serverless app? So I don't necessarily have this giant monolithic application. In a serverless app, you've got lots of different cloud services. They're glued together with Lambda functions. It can be hard to keep track of all of that. And then finally, if we're going to deploy a serverless application, we'd like to do that serverlessly. If we're building workflows for deployment, we'd like to not have a big build server in the middle of all of that. And so obviously, these are not the only pain points that you may have run into if you're getting involved in serverless, but I have to believe you've at least seen some of them. And so we're going to address these today. I'll run over just a few things here. We're going to manage serverless apps with SAM. That's the serverless application model. We'll look at what the serverless application model is, how it's used inside of AWS. We'll look at how to lay out a deployment pipeline using what are called the AWS Developer Tools, and we'll do that actually cross-account involving multiple AWS accounts. We'll go over some best practices involving testing, and we'll get into something very cool there called dynamic feature branch pipelines, which is something we've kind of innovated on here at Trek 10. I'm excited to share that with you. And then we'll look at secrets management, cross-account security. We'll get into that multi-account model. And we'll finish up with probably my favorite part of all this, which is rolling out gradual code changes, traffic shifting and things like that using something called safe Lambda deployments. So deep breath, let's dive right in. The first thing we're going to look at, of course, is SAM, the serverless application model. If you are not familiar with this, you can think of it as kind of a declarative template. It's basically a YAML file you put together that lets you define your serverless application in a single declarative place. If you're familiar with CloudFormation, SAM is going to look very familiar to you because basically it's an extension to CloudFormation that makes it easier to define and deploy serverless resources. So things like Lambda, API Gateway, DynamoDB, config for those is going to be more minimal, easier to read in SAM. But really, I think it'd be a mistake to focus on SAM just as an extension of CloudFormation. And that's because there's a lot more to it than just the templating piece. There's a CLI for SAM now, SAM CLI. You may know it by its previous name, SAM Local, which does support some amount of local testing scenarios. A lot of magic around code rollouts. I touched on that briefly. We'll look at that later today. And then they've just recently rolled out the ability to use SAM even inside of the AWS console to view all these pieces of your serverless application put together. And I know Chris has spent a lot of time working with SAM. Are there any other big pieces of SAM, Chris, that you wanted to mention?
Oh yeah, I mean, I think in general the way we view SAM is it is the full lifecycle tool for managing and running serverless applications. And so one of the great things you can do today with the SAM CLI is start a completely brand new serverless project in the language of your choice. We're going to give you a bunch of awesome scaffolding bits like the SAM template, like a build spec file for AWS code build, which I know we're going to talk about here in a little bit. But it's a great tool to become familiar with, lots of interested integrated aspects with the rest of the platform, and I think a lot more interesting things to come in the future.
Fantastic. Well, we could keep talking about SAM all day. I think it's a lot more fun to look at it. So I'm going to skip over to a code editor now, and you're actually seeing a SAM template on your screen at the moment. I've got a sort of a demo project checked out here, and this is a little Hello World serverless project. It's a REST API. It's got a Lambda function associated with it. If I go to handler.js here on the left, you can see it's just a standard Node.js file. It's doing some routing here on gets and posts, and if you look down to the functions, it's interacting with a DynamoDB table, so nothing too earth-shaking going on here. But sample.yaml, this is a SAM template. This is where our serverless app is actually put together. I want to call a few things to your attention. Notice we've got this transform here up at the top. This is essentially just allowing us to take this SAM template and expand it into a raw CloudFormation set of resources. We've got some parameters. We'll come back to this traffic shift and configuration parameter a little later. And then we've got these resources. So you can actually mix standard CloudFormation resources and SAM resources together in the same template. It's one of the most powerful things I think that SAM allows you to do. But the resource you're seeing up here at the top, this is a SAM resource. You can see that by the type AWS serverless function. And this is going to translate to a Lambda function under the hood. So if you've worked with Lambda, a lot of these properties will look familiar to you. We've got this handler here, which is effectively just giving us the entry point into our code. You can see that right here, module.exports.sample. We've got the runtime, which is Node.js, the amount of seconds it can run, the amount of memory it will have, some environment variables. And then where SAM really starts getting interesting is in this events section. So what's going on here? You can see we've got two events defined in this function, get table data, post table data. Each is associated with a route, sample/ID, and a method, get versus post. So if those look like API routes to you, you're absolutely right. These are, in fact, API gateway routes. And so behind the scenes for us, when we transform this SAM template into a CloudFormation template, SAM is going to implicitly create an entire API gateway REST API that'll wire those routes up correctly. It'll create the API gateway deployment and the stage. We would have the option here if we wanted to establish some authentication methods. And that's all going to be created for us with extremely minimal configuration. Very exciting if you've had to work with the raw versions of those resources before. We've got some inline IAM policies defined here that give us access to that DynamoDB table. SAM comes by default with an IAM role that lets you access CloudWatch for logging purposes. This policy would just be added to that, but we could also add a completely separate role if we wanted to. And then we look down past the tags, and the last things we have on this function are a couple of properties relating to, again, those phased rollouts. So we'll look at that more in a little bit. We've also got a sample DynamoDB table here. This is another SAM resource. You can see it's a simple table, and not a lot that's too interesting here. It's just a DynamoDB table with a primary key and some provision throughput that we've defined. There's one more Lambda function in this SAM template. This again relates to the code rollout, so we'll pass that for now. And then the last thing we have is just our standard CloudFormation-esque outputs, where we have the API gateway URL and the DynamoDB table. And one quick thing I want to call to your attention, you'll notice that in this API URL that we're constructing and putting out, there's a value we're referencing called Serverless REST API. We didn't actually see that anywhere in our template. That's coming from that implicitly created API gateway. So even though we can't see that API gateway itself inside the SAM templates, we can still refer to it just as though it exists, because it will exist by the time this gets translated into CloudFormation. All right, so that's what a SAM template looks like, and we'll continue to use this project over the life of our webinar today. So obviously, we have a SAM template defined here on our local machine, but it's not doing us a whole lot of good until we get it up into the cloud and we get it deployed. Chris briefly mentioned the concept of a code build spec, and I've actually got one of those here in this project. So you can see I'm doing something called an AWS CloudFormation package here, and this is how I get a SAM template ready to deploy. There is a SAM CLI that you could also run. You could run AWS SAM package, but that's just going to alias the CloudFormation package command under the hood. So we'll pass in our sample.yaml here as a parameter. We'll also pass in an S3 bucket to upload to, and then what the package command will do is it'll take our API handler, it'll load in any NPM modules we need, it'll wrap that up into a Lambda deployment package, a zip file, it'll put that deployment package into S3 so that it's available at deployment time, and then it'll give us an output. So in this sample transform.yaml file, we'll actually have our raw CloudFormation that we can then deploy using an AWS CloudFormation deploy or AWS SAM deploy command. And we can do all of that right here from our local machine. But because, again, this is a talk on serverless workflows, we'd much rather do this through a CI process using a pipeline. And so that's what we're going to look at now. So I've got a diagram here coming up on the screen. And this is an awful lot of information, so don't be overwhelmed at the moment because we will revisit this several times. I want to call a couple things out to you, though, right now as we get started. You'll notice there's several areas in this diagram that are outlined in blue. Development account, production account, and then over toward the left, shared services account. And this is that multi-account deployment model that I was talking about to you. The idea here is we don't just want to deploy, all of our different versions of our app, our development environment, our staging environment, our production environment, all in the same place. We really want to create a security boundary around these accounts, and we're doing that with separate AWS accounts. You can use an AWS tool called AWS Organizations that'll let you manage these accounts and will actually allow you to potentially have multiple, let's say, development accounts. You can view these blue areas as more logical divisions than like corresponding one-to-one to individual AWS accounts. But look at what we have here. So inside that development account, we've got a stable development environment. You could also potentially put that in a staging area. We've got this feature dev environment, which is going to potentially, there will be multiple of these as developers are working on features. And then down here toward the right, we've got our production account where we would have our version of the app that's actually serving users. The third account in this picture, the shared services account, that's where we would put things that don't necessarily fit logically into just development or just production. So we might put our source control repository there. We might put our code pipeline there. We might put our code build that's doing our build jobs. And I'm using a lot of words there to describe different AWS Developer Tools. So let me show you the tools we're going to be working with today. AWS Developer Tools is kind of a bucket term that's used to encapsulate several different services you might or may not be familiar with. So the ones we'll look at today are Code Commit, which is AWS's hosted Git repository. Code Build, which lets you run build jobs in ephemeral Docker containers. So it'll spin up a Docker container, run a bash script for you, and then spin back down. AWS Code Deploy, which we'll look at when we get to the code rollout piece. And then Code Pipeline, which kind of ties everything else together, lets you orchestrate stages for building and running tests and actually doing deployments across different AWS accounts. Those are all things we will look at today. Let me dive into my AWS console then real quick, and we will look at what these tools actually look like. While I'm getting there, Chris, do you have anything you wanted to comment on regarding any of these developer tools from a way of introduction?
Yeah. I mean, so the developer tools suite really is a suite of various tools that can be used together. One thing to note is that they can also be used completely independently of each other. They can be plugged into other tools you might be using. For example, if you are hosting your code on, say, GitHub, you could use that instead of Code Commit. If you are using, say, Jenkins, you can plug that into Code Commit and into Code Deploy and Code Pipeline. So really, these are, much like most of the AWS platform of services, meant to be things that can be plugged in together and into other components, even third-party or open source components, to help you solve your developer workflow needs. So this is definitely not the only way that you could do this, but again, one that involves a collection of AWS services.
Absolutely. So we're in the AWS console now. We're looking at this code commit view, and you'll see, as Chris was mentioning, AWS has done a nice job actually fairly recently of making all these different services available to us kind of in one navigation menu. But code commit is that a repository tool. I've got a couple repositories created here. The one called build image, you don't need to worry about too much. I'm actually just using that as a separate repo/pipeline to manage my Docker images that'll work with the code build jobs. But this demo project that you'll see here, this actually is just the remote copy of the same repository I was showing to you locally. So we've got our same handler.js file, and we should have our exact same SAM template as well. And if we poke around in here, you'll see the only branch existing right now is master, and we can, if we want, create pull requests, and you can actually add individual files right here in the browser if you want to. The other services I mentioned, code build and code deploy, code pipeline. You'll notice if you look up toward the left here, I'm actually in a shared services AWS account right now. So the idea is that we would manage our code here, and we would actually manage our pipelines here that would go to multiple accounts. So let's look at a pipeline. We've got a master pipeline for this project, and it's going to do several things. It's going to pull our source from code commit. It's going to do a build through code build. It'll do a create and execute of a change set to CloudFormation, and then it'll go on from there. We'll look more at this pipeline briefly. But the main thing I want you to notice right now, I'm going to go over to the CloudFormation service here inside my shared services account, is that everything I just showed you, so the code commit repositories themselves, the code build deployments, the code pipelines, that is all backed by CloudFormation. So like here's the pipeline itself. Look at the resources that are being managed here. It's the code build project, the code pipeline, an AWS events rule that you can subscribe to if you want to get notified about events that happen on that pipeline. That's all backed by CloudFormation. It itself is code defined. It's kind of like a meta layer on top of our application. And that brings me to the a really important point I wanted to make, which is around the question of why. Why are we interested in AWS Developer Tools? Chris gave us some good comments there, but I want to just focus it a little more and say it really is important to be able to manage your pipeline infrastructure the same way that you manage your application. So we just saw, the application is backed by CloudFormation, by SAM, so we have the pipeline backed the same way. That gives us the integrated security model. IAM, you're going to control your pipeline access the same way you're controlling access to your applications. You can audit through CloudTrail just as you can with your app. AWS Config is going to give you some insights there. Not to mention, when you work with the AWS Developer Tools together, the boilerplate of working with the underlying services is abstracted away. I have CloudFormation weights here as an example. I was just working over the last week or two with another build system, and I was actually having to write some bash scripts to reach out and deploy SAM templates and to call CloudFormation. And I was having to, call the AWS APIs to pull the CloudFormation service and see when a deployment had finished, just real boilerplate type of code. And all that is taken away from you when you're able to integrate with Code Pipeline, because it's all being done under the hood. It's really very plug and play. And then finally, and very importantly, we are in a fully serverless model here. So there's no build server anywhere involved. And that's really what we want, right? Creating a build server and maintaining a build server is not necessarily providing value to our end users. Their value is in the application being deployed and updated in a timely fashion. So it's nice to farm some of that undifferentiated work here out to AWS. All right, so we've got an application here locally defined in a SAM templates. We'd like to make some changes to it, let's say, and push it up to our remote repository and see those deployed in AWS. But the first thing we'll want to do is actually some testing. I'm not going to spend a ton of time on this. I'm going to call out a couple best practices here, and Chris may have a couple others. But these are things that I've seen come up again and again because people always ask about it. It's tough to try to test a serverless application because it tends to be so tied up in cloud services. So I have a note here saying when you can and you have function code that's local that you can unit test, go ahead and do that because it will potentially be faster. You have a very short feedback loop there when you're writing and testing code on your local machine. But whenever you have interactions between services, for example, services that have different permissions, you'll definitely want to test those in the cloud. They're not really going to be tested until they've been tested that way. So I have as a rule of thumb at the bottom of the slide, the more cloud services you use, the less value you will get from local testing. It's really going to be important for you to put these services in the cloud and test them there. When you can test locally, so when you have like a function-heavy application that's got a lot of code that you're writing yourself, the SAM CLI actually does have some local capabilities now where you can spin up a Docker container on your machine. It'll emulate inputs and outputs. But again, if you're working with a service that's not function-heavy, like say you're building on AWS AppSync, which is like a managed GraphQL service, you're going to be behooved to do more of that in the cloud. Chris, what other thoughts do you have here on testing?
Yeah, I think these are all incredibly valid points. And, there's a couple things also that make testing serverless really interesting. One is the cost structure. So for a lot of serverless products, obviously you have no concept of idle. There's no minimum costs or charges involved. And so doing the testing in the cloud can be incredibly cost efficient for you. And when you're not using your, say, testing or staging environment, you're not paying for it. I think also to the point around how the more services you use, less value you get from local testing is very much true in terms of how we see customers building serverless applications, where they're very much leveraging, say, a microservices model, and there's various different, say, upstream and downstream dependencies, potentially other API-based services. And so that complexity is something that you could never really accurately portray locally, and it just kind of becomes something that you would never be doing a good enough job. And so I think for developers, figuring out a good structure for testing actively in the cloud is something that you're going to need to do kind of regardless of the ability to test Lambda locally.
Absolutely, and that actually cues us up really well for what we're going to talk about next, which is dynamic feature pipelines. So I mentioned this really briefly in my overview, but it's exactly what Chris is saying. At some point, you're going to have to put this code in the cloud and see if it really works. And if you've got multiple developers or multiple different development teams, you can't just have one development stack they're collaborating on. It's going to be chaos. So really, people need the ability to dynamically spin up test stacks that they can work with. And what we've done at Trek 10 to solve this problem is we've automated a way to dynamically create stacks to spin up SAM templates whenever a feature branch is pushed to that remote code commit repository, and then it would get torn down when the branch is deleted. So it would live over the lifetime of the feature. And I have called out here exactly what Chris said. This is very cost effective for serverless because you're not paying for idle. You have multiple developers with these live feature branches, and it's not like you're paying for a server running under the hood. And the way this looks, I have called out a part of that big diagram I showed you. So when you push something to a feature branch, so not your master branch, that'll actually kick off an SNS notification that launches a Lambda function. And our Lambda function is going to spin up a CloudFormation template. So it's going to launch CloudFormation stack that will manage a dynamic code pipeline. And that code pipeline will have all the steps we need to do our unit testing, to publish our artifacts, and then to actually do the deployment or update of our feature code to the CloudFormation stack. So that's kind of a Rube Goldberg sequence of steps, but it does work well, and I'm going to show that to you now by actually doing this for you live and in action. So we're at a developer prompt here, and I'm at this demo project, so you can see this is all the code we were just looking at before, and I am actually on my master branch. So I'm going to check out a feature branch, and we will just go ahead and call it demo feature, and I should probably actually check out the branch since it doesn't exist. All right, so we've got a new branch demo feature, and so let's go ahead and make a change. So we'll go to our SAM templates, and why don't we change the timeout? So we'll go from 10 seconds to 30 seconds, since that would make sense for an API function. And so now, if we do a git status, we should see we've got that change. So we'll go ahead and commit this. All right, and we're going to push this to our remote. So I'll have to actually set the stream since this is a brand new branch. And that's going to get pushed to our remote repository. All right, and there it goes. So now if I go back to my code commit remotely here, and we go back to our demo project stack, and we look at our branches, we should see we now have that demo feature branch. And if I switch to that, and we'll look at the SAM template, just making sure that this commit actually came through. There we go. So our timeout is now 30. And now check this out for me. I'm going to go back to CloudFormation and look at this. There's already a stack created in progress, which is demo project, demo feature. And this is a stack that's creating the pipeline that's going to manage the deployment of our feature branch code. So we can look here and see the new code pipeline's been created, the project's been created, and it's just creating that event rule now. So if I jump back to my pipelines view here in code pipeline, I should now see there's a third pipeline that has popped up. There it is, demo feature. Okay, and so you can see it's already pulled the source code from code commit, and now it's going through the build stage. And you'll notice there's a details link right here on this code build. So let's look at what code build actually does. Remember that buildspec.yaml file I showed you that does the package publish. Oops, I actually wanted to go to the details view. There we go. Okay, so it's going to load our build log for us, and you can see it's spinning up that underlying Docker image right now. And in just a second, that should give us some output showing what's going to happen. All right, we'll give that just a second to go.
Real quick, while you're doing this, I also want to highlight that you're actually now currently showing folks the new console experience for the code services. So this is something that was just recently launched here at AWS. And so we now have all of the services in this really nice, I think, unified console experience. Good kind of look and feel parity between all of them. And so if you haven't had a chance to check this out, you definitely should, because it, I think, makes working with these services much more fluid than maybe it used to be in the past.
Absolutely. Okay, and so we've now seen the output come from this build job, and you can see it ran that CloudFormation package command that we had looked at locally. So it's packaged the artifacts, it wrote our output CloudFormation file. We'll just kind of manage that as an artifact throughout the build process so that our other build stages have access to it, and that is now completed successfully. So again, if we just use this nice integrated view and go back to code pipeline here, we should now see that it's going on and it's doing our deployment. Now I want to call something really important out to you here, and that is that we are not doing this deployment in our shared services account. If you recall, and I'll go back real quick to my diagram here so I can show you, you'll see that this dynamic branch pipeline is actually reaching out to our development account. So the pipeline is managed in the shared services account, but we're doing a cross-account deployment here to deploy this feature dev. Okay, so going back to our console view, you'll see I've created my change set here. And so if I pop over and look at that, clicking details, I'm actually going to get an error message because, again, I'm in the wrong account. So if I go to my dev demo account, we should see, so here's the change set and everything has been added. because this is a brand new stack being created for this feature. And you'll notice we've got our API function. That was that handler.js file. We've got our DynamoDB table, and look, there's our serverless REST API. Remember, we were referencing that even though it didn't actually exist yet. That was implicitly expanded for us by Sam. And so now, if we go back to the stacks again here in our dev environment, you'll see it's creating this feature stack for us here. So that'll finish up in just a second. And then if I'm a developer, I'll be able to log in, do whatever other testing I want. Very, very cool stuff. All right. So back to our presentation we go. All right, so let's move on now to some best practices for secrets management. We're going to come back to our live demo momentarily to look at some of this in action, but I want to run over a few basic concepts here as we move our application inevitably toward production. You see I have called out here in highlighted text, no plain text secrets ever in Lambda environment variables. Hopefully it's obvious why you wouldn't want to do that. You are at that point exposing those secrets to anyone who has access to your AWS account. You do run greater risk of just those secrets being committed to source control, exposed in some way. So you definitely want to use some sort of secrets manager. There's a couple options available for you in AWS today. One I have here on the slide is the SSM parameter store, and that actually has a KMS integration, so you can encrypt secure parameters. And then just recently, they've released something called Secrets Manager, which actually allows you to rotate those secrets as well. So if you have something like a database password, that can be a good call. I have a note here saying I actually prefer even not to put KMS encrypted secrets in Lambda environment variables. And that's not because it's necessarily a security risk, but just it's better to have them in a centralized location. If you need to revoke that secret or update it in some way, it's better not to have to go touch every single Lambda function individually. Let everybody pull that change at once. And so, of course, if you're going to do that, you probably at some point will need some kind of a caching solution so your Lambda function is not constantly reaching out to a remote service to fetch parameters. So you need to put those into global space and then have a try catch where it would update that value if needed. Chris, any other best practices there?
I think you hit on all the key ones. One interesting thing to call out is that you can actually now access the data that is stored in Secrets Manager or via, I should say, Parameter Store. So the two have tight integration, and so just by using Parameter Store, you'll be able to query both your parameter stored there as well as those secrets. So really powerful, and again, 100% agree with the concept around it's better to have them in a centralized location, especially as you talk about more and more functions that might need access to those. Saving that duplication and not having to worry about, say, configuration drift is an important thing.
Phenomenal. Thanks, Chris. And so then expanding that out a little bit more to multi-account security. So I talked a little bit about why you might want to separate your different stages of your application into separate AWS accounts, but getting a little bit beyond that. So we're doing these deployments via pipeline. And when we get to the point of even doing deployments in production, it's ideal that people, so individual named users, don't have access to go in and do those deployments. You run some security risks there. It's much better if you can automate that, have it done by pipelines. It gives you a lot better auditability, much more predictability about what's going to change and when it's going to get changed. And so you really even then need the ability to separate deployments from approvals. So you might want named users to be able to go in and give a thumbs up and say, yes, this change looks good. In an enterprise context, that can even be a requirement for you as part of your change management policies. But you might not want those people to actually be the ones going in and deploying, having the credentials to deploy. You'd want that to be managed via the pipeline. So that's why I say you'd want to even manage changes to your IAM entities via pipelines. If those approving users need to change, you should have a pipeline that manages those. And you can even pass deployment roles to CloudFormation as part of this. And I'm getting rapidly, I think, into something that might be a little bit advanced for this webinar, but I want to show you what's underlying the pipelines that we've looked at today with regard to those deployment roles. So let me pop over to a diagram here. Again, there's a lot of moving arrows and boxes on this, but the core of this should be familiar to you because we've got three accounts here: shared services, development, and production, what we've already looked at. The fourth account up at the top left of the screen, that's your user portal account where you actually have your IAM users logging in. Potentially, if you are working with federated users via Active Directory or something like that, that could replace that account. But ultimately, however your users are getting their temporary IAM credentials to actually do work in the AWS console, those people would assume roles in your accounts like shared services, development, production, and you'll see I've got an admin role set up there. So this would be a named user that has an admin role, but they're not going to have IAM rights, so they can't escalate themselves, can't create other users with more rights than they have, and they don't have STS rights. STS, again, is that AWS service that lets you get temporary credentials, so they're not going to be able to assume other roles. Instead, of course, they would be able to push code to code commit, and when that code runs through code pipeline, there's going to be a service role that's part of code pipeline, and that role will have STS access. That means it can assume a different role. So remember when we did our cross-account deployment from shared services over to dev, our code pipeline service role was actually assuming a service role in that development account. Now that service role, even that role doesn't have full deployment access to create whatever it wants. Instead, it has pretty limited access mainly to the CloudFormation service, and it has the ability to pass a role. So it's going to take a third role, which is called our deployment IAM role, and that has full admin access. It just doesn't trust the code pipeline service role. So we'll pass that role to our to our CloudFormation stack, and code pipeline will use that role when it deploys the actual resources. So again, kind of a house of cards of IAM permissions that are being stacked up here, but the ultimate goal of all this is your individual named users don't have permissions to deploy resources, and even your code pipeline doesn't directly have access to do that. It's all being managed and passed through using some of these advanced IAM features.
If I could interject real quick on this, while this does look like a significant level of complexity, one other level that could be added to it is if you do have an organization, let's say, that needs to be have a separation of roles and responsibilities for who can create and manage IAM roles. Today with CloudFormation and therefore with SAM, you can actually pass in attributes via parameter store. And so you could have your team that owns your IAM permissions, roles, and so forth, create parameter store records that represent who these different IAM policies and so forth are, and then have those consumed by the CloudFormation templates that create your pipelines and your applications. And so you can get another level of complexity here, but one that can, again, give companies what they need in separation of responsibilities.
Absolutely. So the point is here, there's a lot of power, there's a lot of flexibility. There's also a lot of potential for people having permissions they shouldn't have. So you have to watch carefully. And there's actually one more cool thing we're going to look at in a moment that'll touch on that. But before we do that, I actually want to get back into our AWS console and show you the next step in our process, because this will take a second, so I won't let it run. So back to code pipeline we go, and of course I'm in my development environment now, so I'll need to switch back in services. So to shared services we go, and you'll recall that we created a feature branch. Presumably we've done some testing on it, and what we now want to do is we'd like to merge this code to master, which will kick off our master pipeline. So I'm going to actually go to code commit and go to my repositories again to my demo project, and we will create a pull request. So master is my destination. The source, of course, is going to be that demo feature branch I created. Let's click compare and see what changed. And there's no conflicts, which is good. But if you look down at the changes, there's our 10-30-second timeout. So this is going to look familiar to you if you've used other source control hosted type of systems. So we'll just call this PR for pull request, and we will go ahead and create it. All right, so once I merge this pull request, which I'm now going to do, yes, so I'll merge. Within just a few seconds after this happens, it might take up to 60 seconds for code pipeline to recognize the change, but we should see a change start to flow through our master pipeline. And this pipeline is going to look a little bit different than the feature branch pipeline we created. Remember, all that one did was just to pull the source, it did the build, and then it did the create and execute of the CloudFormation change set. Here we've got some other steps in the process. So let's look at this. We're going to pull the source, we're going to do our build. We're going to actually deploy to our stable version of the application, which is in our development environment. So we'll do the create and execute of the change set. Then I've got this manual approval step. What's that? Well, I'm about to show you on a slide. So let's go to there. So this is just a really fun thing that I've had some success with. Code pipeline actually allows you to lock down IAM permissions all the way down to the resource level, to the action level, to the stage level. What that means is I can take a stage inside of my code pipeline and I can say only this specific IAM group has the ability to interact with that stage. So if I want to have a manual approval, code pipeline actually supports that natively. I can create a manual approval step inside of my code pipeline. And that would allow potentially, a team lead, a manager, somebody who has that change control approval status to go in, look at the change that's being proposed, potentially look at that change set and see actually what infrastructure is going to be changed. Another big advantage of, infrastructure as code and using CloudFormation under the hood. And then if they approve, they can type that in, and the pipeline will then flow on and it'll actually do the deployment. I mentioned one of the advantages of using Code Pipeline is you get all those great integrations with things like CloudTrail. So you're going to have that approval action recorded, and you can go back and check on it and have an audit trail of who did things. Obviously, the caveat here is it's going to require careful user management because you've got to make sure that you've got people set up in separate groups because you can have multiple approvers, so multiple individual people that have to sign off on something. That's why I have the nuclear option on this slide. It's kind of like that nuclear key scenario where you have two different people on different sides of the room pushing buttons. If you're interested in that, or your organization might have a need for that, I've actually got a blog post here linked on the slide that writes this up in detail and provides code examples showing you how to set up the IAM roles and all of that. So definitely check that out if you want. But if I go back here to our pipeline, you'll see, by the way, now that I pulled my source a minute ago, I've done my build and I'm now flowing onto that stable dev. But my manual approval action here, once this pops up, I'll be able to approve that in a second. And you can see, let's look at the last time I did this. This not a very helpful comments test, but you can see there I am, F. Brazeal. So I am, in fact, logged in the system here, and we can clarify that that was the user who performed that action. So we're going to wait for just a minute and let this flow through. I'm going to have a few more cool things to show you, but I'm going to move on now to the concept of code rollouts and some best practices there. All right. So theoretically, we've got our code at a point now where we've approved it and we want to go into production. And we've talked a lot about having separate AWS accounts. Obviously, that also means separate CloudFormation stacks per stage, dev, QA, prod. A lot of reasons for that. A primary reason just being you really decrease your risk for deploying code in a place you didn't mean to, or overwriting production with dev data. So separating those things out really helps you there. But even within your production environment, you're going to reach a point where you've got code you want to update, and you've got to figure out how to do that without disrupting service time to your users and that kind of thing. So for a long time, the best practice here really was to use separate CloudFormation stacks, even in production, kind of like a blue-green approach, and to just do DNS failover or something between them. And that's still maybe the best practice, depending on what type of resources you're working with. So not every AWS resource today would support the ability to have like in-service failover. But if you're working in like a Lambda-heavy deployment, and it's, of course, SAM-based, you have some options now to do something really cool called gradual deployments. And we are going to look at what that looks like. So let me go back for a moment to my code. All right, so we are back in sample.yaml here, and let's look at some of those cool properties that we just glossed over a few minutes ago. Looking at our resources, we had this sample API function, but there is, in fact, a couple of properties associated with it here that we didn't look at before. There's one called auto publish alias, and this is some SAM magic. It might be my favorite property in all of SAM, and basically what it does is it publishes a new version of your Lambda function for you. It takes the alias, which you can kind of think of as Lambda's version of a DNS name. It's a value that always points to exactly one version of your Lambda function, and it switches over your traffic to be behind that alias. And then, it switches that alias to be in front of the new version of your code. And then we've got the deployment preference here. And this is actually something associated with code deploy, which is that AWS service I mentioned to you before that handles phased rollouts. You may be familiar with code deploy if you have worked in like an EC2 context, and maybe you've used a code deploy agent to update code on a virtual machine. Obviously, we don't have servers in our SAM environment, but code deploy has come on strong with some serverless integrations here. So you'll notice the type of the deployment preference that refers back to a parameter that we passed in up here. This is the code deploy deployment preference, and there's a few of these. Our default here is all at once, but there's several others. You can do canary type deployments where you say I'm going to send a certain percentage of my traffic to the new code for a while, and then if that works, I'm going to move the rest of my traffic over, that kind of thing. So that's our deployment preference, and then we've got a hook here. What's a hook? Well, that's going to allow us to actually run some tests. So integrate other Lambda functions as part of our rollout strategy where we'll ping our endpoints or do whatever we need to do to verify that everything looks good before we move all of our traffic over to handle that. You can do pre-traffic hooks, which take place before that alias switches over, and you can do post-traffic hooks. I just have a post-traffic hook defined here, and this is actually a separate Lambda function. Again, managed as a SAM function, right in the same templates, and most of the things will look familiar to you. There is a handler here. There's a function name which has to start with code deploy hook for reasons that are interesting, but we won't get into that too much. Anyway, and I've got a separate, actually, Python file defined here in my code, and you'll see that it's retrieving the API gateway URL, so it's going out over the public internet, and then it's running some tests on the function to make sure it can handle the get, handle the post effectively. So that's what my post-traffic hook is doing. and it's got a couple environment variables that help it to do that. So it can reference, other pieces of data that are right here in the same template with the app. All right, so that is what the code deploy traffic shifting looks like from the code perspective. If we go back now to our console here, you'll see we've got the manual approval stage, which now has stopped and is waiting for our approval. I've got 2 actions in parallel. By the way, I believe code pipeline currently allows you to have 5 actions in parallel, so that can really help you if you've got a bunch of things that have to happen at once. In this case, we've got 2 of them. So if I had 2 different users with different groups, I could say only a certain set of users has access to approve manual approval action 1, and then I'd have a different set that has to approve action 2. In this case, though, I have access to approve both. So I will do that, and I will hit approve, and off we go. So now in a second, that's going to move on to our stable production deployment. But while that's happening, I want to look at our stable dev deployment. So just like in our feature branch, it created the change set, it executed the change set, but I want to look specifically at how this is happening. Once again, this is going to be the wrong environment, so we'll have to jump back into dev. And you'll see here that our stack update has something interesting in it. Look at this little link here, code deploy deployment started. So look at where the update started here. It did the create of the Lambda version. It started updating that alias, but before the update of the alias finished, it launched this code deploy deployment. Let's look over at what this did. The view you're seeing here now is going to look familiar to you because it's this exact same developer tools view we've been looking at for this whole hour, but our code deploy is actually going to be managed here in the dev environment, not in our shared services account, right? Because there we had our code build, our code commit, our code pipeline, all in that shared environment, but our deployments are actually happening out in our satellite accounts. So that's where we'll manage the code deploy. And look at what we've got here under deployment status. Pre-deployment validation, that's that pre-traffic hook. I didn't have any of those, so I would hope that would have succeeded. And then traffic shifting. What's happening here? This is where it fulfills that actual deployment preference that I specified in my SAM file. In this case, you can see that my preference was all at once, which makes sense in dev, right? Because I don't want to wait. I would like to get my changes out as fast as possible so that I can test them. So I did all at once. I shifted all my traffic over immediately. That's what that 100% replacement means. And then I did my post-deployment validation. So I ran my Lambda function, and it looks like that, in fact, ran my check successfully, and it succeeded. The other piece of this I want to show you, if I go now to the Lambda service, because we actually haven't looked at this deployed application yet, check this out. You'll see my functions here. I've got my traffic hooks for my feature branch and my demo. But if I click on applications, look at this. There's 2 applications. One's my master, my stable deployment. The other's my feature branch deployment. And if I click on one of these, like I'll click on the master one, look at what we have here. This is all the resources that were created by my SAM template. So the IAM roles, the Lambda functions, the DynamoDB table, the API gateway API, all of the sort of ancillary permissions and other resources that CloudFormation and SAM generated for us under the hood. And I can pop down my SAM template, see what's available there. This is all collected for me in the same place. Really can help you with just getting your head around the logical sprawl of your serverless resources. They've even got a little bit of monitoring integrated here coming from CloudWatch, and you can see Lambda or DynamoDB. And look, API Gateway has just been added. That wasn't there like a week ago. So the team's obviously actively working on this. Very, very cool stuff. Okay, so let me go back now to my shared services account, which again, I gotta switch my contexts. One downside of.
And again, to be clear there, so the applications view in the Lambda console now is made possible only if you launch serverless applications using SAM or just regular raw CloudFormation. And so we're actively looking for feedback on it. As you highlighted there, the monitoring tab, which is currently in beta, is expanding literally every couple days here probably. And so again, really excited about it and looking forward to hear what people have to say.
Absolutely. Okay, so we're back at our master pipeline now. And so we've done our deployment that succeeded, our approvals we've done, and it's working on our prod deployment. And look at this. So it's been 2 minutes in progress and our execute change that is still happening. That seems like a long time. Let's see why that is. All right, so here we are in our details. Of course, we've got to jump into our production account now. And here we go. And look, our stack update's in progress. That started about 2 or 3 minutes ago by my time here. So let's go to our code deploy deployment and see what's happening. All right, so we're in the production account now. Our pre-deployment validation, again, there were none of those, so that succeeded really fast. And now we're doing this traffic shifting, and look, it's stuck at 10%. So 90% of our traffic is still on the old version of the code, but 10% has moved over to the new version. And you can see we use this For our production app, Canary 10% 5 minutes. That means that for 5 minutes, only 10% of our traffic is going to be served in the new code, and then assuming everything's good, it'll move the rest of the traffic over. So I could let that complete, but we've already seen this application deploy successfully 2 different times now, so I think it's going to be more interesting to actually click stop and roll back deployment. So I'm going to click that, and you'll see that this is going to handle the code deploy stoppage for us. And it gives us a warning, and now within just a second here, we should see an error pop up saying cancel due to an abort request. If I go back to CloudFormation here inside of my prod environment, and I look at the events, and we'll give this just a minute for this to pick up on. Okay, there we go. So code deploy rollback started, rollback successful, and in a minute we should see the actual CloudFormation status. There we go. Go to update rollback in progress. So think about what's happening here. We have, from inside of code deploy, we said, nope, my code's not good, roll it back. Code deploy sent the message back to CloudFormation. CloudFormation is rolling the entire stack back, so any resources that were created are going to be rolled back. We're going to get back to the infrastructure-defined state we were in before we started this deployment. And then CloudFormation is going to pass that back to Code Pipeline, which is all the way back in our shared services account. And Code Pipeline itself should, in fact, record that we've got a failed production deployment. So switch back to shared services. This can take a minute because it's got to do that rollback, and then Code Pipeline's got to pull and figure it out. Isn't it nice that we didn't have to write any of the underlying code to figure this out? There's so many things happening here, just boilerplate things with waiting on the deployments and handling all the different edge cases in terms of what the final statuses can be. And we didn't have to write any of that code. And look, there it just popped up. It failed. I can click on the details, and it tells me it was update rollback complete on the stack. And so if I wanted, I could click back on the execution details, and that would take me back into the production environment. So I've got this really nice visual summary of what happened across my entire deployment. All right, very big breath. That was an awful lot of stuff really fast. I'm going to take us back now again to that diagram that I showed back at the beginning and just remind ourselves of what we've done today. So starting over on the left where the developer pushes the code, we made an update to our SAM template, and we pushed it to a feature branch. That launched a dynamic branch pipeline for us, which we could potentially have had many of those existing simultaneously. And it did everything to create a dynamic code pipeline, test and deploy our code out in our development account here. We did a code review. We merged our code to the master branch, referencing our artifact bucket and all that sort of thing. And then that actually launched our master pipeline, which again did our build. It did a stable deployment in dev. Our Lambda smoke test happened actually as part of the code deploy stage, but you can have Lambda invoke stages as part of code pipeline as well if you want. And then we did our manual approvals, and then we deployed to production, followed by, again, another round of testing that happened as part of that post-traffic hook, or would have if we'd allowed the production deployment to go that far. So a huge amount of stuff, very cool. Chris, any final thoughts here?
We've gone through definitely a whole lot here in a short period of time, and I think that there's been kind of a bunch of best practices, guidance that's been put through this, and again, just to make it clear that as part of what was been demoed here, you haven't had to set up any servers or SSH into any things, or deal with networking really at all. All of this is completely managed. Pay for what you use. Pay just at the time of usage, essentially, services. And so really kind of transformative when you think about what this could mean to your business or to the applications that you're building. And again, this is just part of the capability of what each of these products has.
That's exactly right. We've barely scratched the surface of many of these tools. And the title of this talk was Serverless Workflows for the Enterprise. And you could really look at that one of two ways. The application we deployed was serverless, and then the entire workflow itself was serverless as well. So even if you're not deploying a serverless app per se, you can still get value out of having a workflow pipeline that's set up in a serverless fashion. And I think we've underlined some of the reasons for that. All right, well, obviously, I spend a lot of time working in this space. I would love to connect with you if you have questions. You see my Twitter, my email there. You can also find me through the AWS Developer Center. That's where all the serverless heroes are, and there's a lot of other great AWS-focused information there as well. So I'd love to hear from you, and I think that'll do it. Thank you so much for your time and attention today.
Yep, thanks everybody for joining us. Take care.